Yeah. Thank you.
Okay. So yeah. So let's start with asynchronism. Uh, Asynchronous workflows help reduce request times for expensive operations that would otherwise be performed inline. They can also help by doing time-consuming work in advance, such as periodic aggregation of data. Okay, so most of the times when we are dealing with some extra service calls, or which might need some network calls or something like that, uh, we tend to keep waiting until and unless the response is generated from any service call. So that is something they are called as performed inline. So like the execution waits until we get the response from any network call or any service call, and that makes the client busy for that much amount of time. Whereas this time this turnaround time is a overhead of some different service. It should not be overhead for a client, for the client, but yet since the client keeps waiting for the response, it becomes overhead for the client itself. So if there are 5 or 10 microservices involved in the background, all of the responses will add up, and thus the client will, like, the performance of our whole application will go down. So in that case, they say asynchronous workflows help reduce request times for expensive operations. So our execution won't stop at that line itself. It will go on executing further logic, and then it might come back to check if the response is ready or not, something like that. So it says they can also help by doing time consuming work in advance, such as periodic aggregation of data. So maybe as soon as our execution start, we might have some routine, some cron job triggering, and or maybe some periodic triggering of a cron job, and it will keep the response ready. Whenever we need it, we will just use the response, or we will just retrieve the response wherever it is stored. So what are the ways of doing asynchronous kind of workflows? Message queues. Typically, message queues are one of the most famous one initially being used. Uh, Message queues receive, hold, and deliver messages. If an operation is too slow to perform inline, you can use a message queue with the following workflow. An application publishes a job to the queue, then notifies the user of job status. Okay, so it says an application publishes a job to the queue, then notifies the user of job status. A worker picks up the job from the queue, processes it, then signals the job is complete. Yeah, I guess Deva, maybe you might be able to better explain this part. How exactly the job is published and consumed, and then again the response is published, and then the response is consumed.
Um, I'm also okay. So is this the message queue piece, right? I mean,
Yeah,
okay.
maybe in terms of Kafka, you might be able to explain this one.
Okay. Usually, typically when we send it to the message broker, right now, we are not using any acknowledge, but we are using the same stuff in our application. So when we say, if we are doing an asynchronous call, what we do when let's say a microservice receives a request, but it is an asynchronous call, what we would do, we would right away reply back to them with the 200 status that, hey, we received your request, but we will not tell them like whether it's successfully done or not. And then what we internally do, we use that Spring module, I mean Spring Kafka library to send a request to the broker. And then that's where we use the internal libraries to send the request. And then the request goes to the broker, and it will put the data into the broker, and then the consumer can get the request anytime, and then it can process it. So that's the idea. So an application publishes, but I'm talking from the online, but this can happen for the batch process also. Let's say we have like some kind of a timer process or cron jobs running at any time. So what it can do, it can wake up at that time, and then let's say it needs to do some aggregation work, or any that particular work it needs to do, it can wake up at that time, and then what it will do, it will create a request and it will push that request to that particular queue, or particular topic. Sorry, for especially in the Kafka perspective, it will push that particular object into that queue, and then it finishes its work, and then that request, it's in the data is sitting in the broker. Then the consumer will be always listening to that to see there is any data available in that topic or not. That's the thing, the second line that they're explaining. The worker picks up the job from the queue. Basically, I'm thinking it's a consumer. So the consumer picks up the object, which is the job, from the queue, and then it processes it and then signals that the job is complete. Is that clarifies?
Yeah, that perfectly explains the basic functionality. One question here, Deva.
Uh-huh.
What about the response for the request? Like, if the user publishes something to the queue, or maybe some caller publishes something to the queue, and or might publish something to a topic,
Yeah.
uh, but the response that server sends back to that same request, is it published for the same topic itself, or it could be different topic for response?
Oh, usually it's just a one way of flow, in the sense like we may not as like not like a synchronous way. If it's a synchronous call, the user would be requesting because we are holding that session with them, so that we can reply back to them, hey, we are finished with the job, or let's say 400 or 404 if we found some error or client error, something like that. But if it's a job based, right, or if it's an asynchronous based, that's the challenge. We may not be able to reply back to them right away. But what we do, we have some kind of a reporting topic. So what we will do, let's say there is a timer process or something picks up, it does the work, but what it will do, the response, but I think the way how we are architecting, but the response, what it can do, it can go and respond back to a different topic, maybe a reporting topic or way idea. So that reporting microservice, what it will do, that consumer will wait for that. If there are any request comes in, it will work on the reporting things, like let's say it's a bigger process, and whether it needs to reporting through email, or it needs to reporting to a text message, or it needs to, but it is not at the same way, because once the request comes in, the client will lose the connection. So
Okay.
what we would do, we need to reply back to them in other mode, either email or some other process, or we can write it in a file and put that in a location. That's how in the place that I work, we kind of architected in a way. But I'm not sure, like, if there is any other way. But this is just one of the way.
Okay. So
Um,
maybe yeah, I understood previously maybe this way. Correct me if I'm wrong. Let's say if there is some endpoint for items like slash items,
yeah.
and let's say if we create a topic for that, so we can create a topic named item request, and whatever the user or whatever the client is requesting, it will publish that request to item request topic,
Topic.
and
Yes.
consumer, the server will keep listening to keep polling if there
Yeah.
is something published for item request. It will retrieve, if there is something, it will retrieve it. It will produce return around the request, and while posting a response, it could post it to some different topic named as item response,
Yes.
to which the client can keep polling. If there is something for client response, periodically it can keep polling. If there is something in client response, it can retrieve it, something like that.
Yes, but the client polling, right? I mean, how that would work? Because I'm thinking in the context of this is for the internal, right? Internal, we can put a topic and then it can queue.
Maybe
The
some
consumer
thread,
can.
maybe some parallel thread might be doing that.
Okay, okay,
So
yeah, that is also possible. So that will be like, any online sites or anything. Realistically, it can poll and it can get the response. It will be a delayed response, but it can quickly get the response back, right?
yes. Yes.
Yeah, I got the idea. So that is where the webhook also a little bit comes in, but it may be a slightly different
But
approach. But mhm.
to deal with this kind of asynchronous communication, Deva, we usually have callbacks. If anyone
Yeah.
here who
Mhm.
worked on JavaScript, sorry, you were saying something, Deva.
Oh, no, I got your question. Like, definitely there will be a callback URL. So it will call the URL to get the response, right? That particular URL.
Uh, yeah, maybe like through functionally we can also write. So I know about Scala. I know about JavaScript. Like especially Node.js. I have worked on one project where they were writing callbacks after some time, like after a few
Mhm.
lines of code. Initially, we will just make a async call, and then we will await for the response, and then we will write a callback once everything executes and it reaches to the end. The callback will execute, and callback will check if the point where we were making await, if the response is ready there or not. If the response is not ready, we can have a nested callback, like callback to a callback. Then it
Mhm.
will again check back. If it is ready, then we will simply return that. If it is not ready, then it will keep waiting after the final callback, because everything in the flow was has already executed. So in the final callback, it will keep waiting there. So this is the nested callback structure that they used to write in database calls, uh, for database querying or for general operations basically.
Okay. Okay. Yeah. Is that maybe I'm also not clear. Like, is that the call the front end the JavaScript type pieces it is doing? So let's say we are doing a REST call, and let's assume that it is just a REST call, right? The callback also a different URL, or you will be calling the same URL again. So in the
No.
sense, like, you have a resource that you need to call, right?
Yeah. Can you you can continue.
Yeah, so my thought process is like, then definitely the client side is doing an asynchronous approach, right? So what it will do, it will do the rest call, and then it will not keep the client resource waiting for the response, because it can do other job, right? Rendering or something. And then after a particular time, it will come back to see the callback object is available or not. If the object is received from the server, then it can, so that it is not, so that's the asynchronism I'm seeing it in the client side, but it is not on the server side. Uh, um, let's assume that it is doing a REST call, and then the REST should respond back, right? So let's say now we have the asynchronous applied in both client as well as in the right?
Mhm.
So sorry, in the server side. So what can happen? The JavaScript thing can call a REST call, and then it can do some other tasks, and then at a certain time it will come back and see whether the response is received or not. But let's assume that it called a REST call in the server side, and the server side, maybe it is a time-consuming task. So we are trying to achieve the server side implementation in an asynchronous mode, right? So there, what it can do. Let's assume that it is going to give a quick response that, hey, I received a request. I mean, request received, which means we are not saying we processed it or not. Let's assume that we are saying request received. Then my understanding is, then the UI will reply back that, okay, request is received. But how it will, how the further communication, that's where I still have a question. So now let's say it is like a 15 minutes work that the client should do. And now what it will do, it will send the response back as like request received, but the server will put things into the topic, and the topic will be received by some stuff, and it will work. And then how it will come back and communicate to the UI, that's where I have a question. Like, I'm also not sure how that
Okay.
link will happen.
Okay. I guess the one that you're talking about is also one of the way. What
Uh,
they are saying here is like they will have some function something like this, and then
uh-huh.
separately the request will go and they will try to handle the response through that. So usually they say the following works just fine. Will give the same result as above. Like let's say if we are requesting something and we are handling the response. Here we have the function itself. it can make a call by itself, and then later on we are handling the request. So here this could act like we will check back and we will again call the handle response function, and with the same endpoint if the response is ready or not. So something like initially we make a call and then again we check with the same endpoint, and the handle response will see if the response is ready or not. So repetitive calling of the handle response will check if the response is ready. Just return that response.
Okay, but okay. So you are saying the yeah maybe okay callback. Okay.
Yes, another one is like they say the callback function is put on a sort of queue called the event loop until it will be executed with the result from the request. So callback loop is something like it will keep it will keep coming back to whatever there in the event loop.
Mhm.
If all instructions are executed and this is just the only instruction which we need, like the response is the only thing that we need, it will just keep waiting for the response.
Yeah, this is the asynchronous approach in the UI side, right? I what I
Yes.
see that like we created a function kind of how it should handle, and then we are passing a request which is a HTTP, that is our endpoint, and then we are passing, hey, this is the endpoint handle, and then we are passing that function as a parameter, right? How it should handle if it's a failure or if it's a success, what it should do, right? So this can happen in the event, but the asynchronism is achieved only in the UI side right now, not on the server
Yeah.
side, whatever the REST call it is doing. The question I have comes in picture: what if UI also asynchronous, but at the same time the server also asynchronous?
Yeah. So
Uh, that
for that, so I know about Scala.
uh-huh.
In our case, like it's like there is something called a stitch function. So maybe we can have a look at stitch as well. Stitch helps us in handling the response being generated or not. So maybe if I can show you something.
Which is the completable features idea, right? Like what
Yes,
Java
future.
provides. Okay.
Yes, exactly. So Stitch is Stitch make use of future, and future is like it will query some data, query some endpoint. The response will get stored there forever, and that too on client side basically. So whenever we hit up we have a callback, we will just check with the future if the response is ready or not. If the response is not ready, it will just simply return null. So as long as we are getting null, we will keep calling back. So
Okay.
some logic like that might work. Or let's say if we can have a timeout as well. So we made a request.
Mhm.
After that request goes through, after some time, we check with the future. If the response is ready, it will be delivered. If the future is still null, we will just simply throw a timeout exception.
Yeah. Yeah. Okay.
So this is the way they do in speech calls. Yeah, I guess not sure if they have mentioned it here or not. Oh, okay. And I guess this is what you're talking about, right? Status and endpoint.
Oh, okay.
So
Okay. Oh,
we,
makes
we make
sense
a
now.
request. We make a request, post request on
Uh-huh.
API endpoint. It just returns us a response right away.
Okay.
And then the client keeps checking on the status endpoint. The status endpoint, if the status is ready, it might invoke the resource URI, and then it will return the response.
Yeah, yeah, this is the pattern I was not clear. Yeah, yeah, now it makes sense. Like, no, I was not clear on that. So basically, now I get it. So we call the API first and we give them all the request data, and then the API is responding back 202, which is submitted, right? I
Yeah.
think some kind of a thing. And then the client responsibility to keep on polling and finding it out whether the job is done or not. Oh, okay. 202 accepted. Okay.
Request.
So basically the server is saying I accepted your request, and then the client should figure out what status it is. And if it is fully done, then it will do a get call to get the real output after and returns a 200,
Yeah.
which is okay.
Yeah.
Oh, makes sense. Yeah, yeah. Okay. This was the one piece that I was not clear how the UI and the service both will work, because now here the client also will be asynchronous, but at the same time server side also can be
Yeah.
asynchronous,
So
right?
I
Okay.
guess this need not to be UI. It can also be some server to server communication, right?
Okay.
Like
Yeah.
the
Yeah.
client server will keep checking with the status endpoint, something like that.
Yeah, makes sense.
So if you see, there are basically two get calls for the status endpoint. These could be from callbacks.
Yeah, but it is the same get call, right? I think, but here they are saying the scenario for 202 and 3. Do you know what is 302? 202 means, I think it's saying still submitted, but I think when it goes to 302, I think it is like a found, which is the status changed because the asynchronous job finished its work,
Yeah.
right?
So
Now after 302, then they are doing a get call for the resource. Go ahead.
yeah, and which is returning 200.
Yeah, makes sense.
Hey, Sagar, can you share this document on the chat? And also, is there any, I mean, I don't know how many in the call are familiar with this asynchronous concept, but is there any other more basic, like giving a broader overview, like where these asynchronous things are used? Because at the low level in the programming, definitely in the Java, there are asynchronous calls and all those things, right? But I think you guys are talking about, I mean, I don't understand the concept of message queue and Kafka. So is there any more basic thing we can check before going to
I
the
will
top?
say, yeah, I will say in all the microservices architecture, wherever the server to server communication is involved, we usually try to, and since it's a high, like highly scalable kind of application, we never want to let the client keep waiting for the response. So I have not sure where exactly, but I have read this thing that we never want the calling server to wait. It should always be asynchronous if we are if we are talking about multiple microservices. So here, maybe for example, in terms of e-commerce services, let's say some order management service is working. The order management service might be checking with some stock or some inventory management service, but at the same time, it might be dealing with analytics. It might be dealing with some billing service. It might be dealing with some payment service in parallel. So there should be 10 to 15 services that works in background. So we never want the order management service, which is a caller service caller client here, to wait for all these responses to be ready, or all these requests like to be processed first. So in general, the microservice like in general microservices needs to go asynchronous way. Only if we have a simple system like this, like everything is in cascaded format and we don't need to wait for more components, we can have a synchronous service or synchronous communication between producers and consumers.
Okay, makes sense. Yeah. Yeah.
So in general, like in highly scalable services, by default, it could be a synchronous communication.
Yeah, because at the gRPC level, we try to implement asynchronous, like even if the application is talking to, let's say, database, we try to implement the asynchronous calls with the database because we don't know when the database will return, right? So,
Yes.
so those are at the code level. We try to say use the library, async library, or whatever you call. But I think using those libraries itself, we can make the we can sorry.
And Daddy, listen. If it is less than 99, that means I'm really good.
Okay, somebody please mute. Okay. All right, thank you. So what I was trying to emphasize, like the way these things come up is basically at the lower level, we are trying to use those async library, and then that's how we are making whole microservice as a asynchronous. For example, microservice A is talking to a RDS or a database, right? So the sending of request to fetch a bulk of data from the database and getting the response might be asynchronous while we are still processing other things, like you mentioned about the e-commerce thing, right? So actually it comes from the library itself, then service become asynchronous, and then that's what it happens, right? If I'm not wrong.
Yeah.
or or there is a more elaborated concept? I don't know about Kafka. That's why I was trying to understand.
Yeah, so I guess yeah, so as Deva also mentioned initially, and what you are saying, this is like the library abstracts everything for us, right? So what we are talking about is how the library is implemented, like the implementation detail of the works.
And I see, I
So
see.
for
Yeah,
us,
definitely.
it is abstracted, like as Deva mentioned about the Spring Kafka library. For Scala, I'm talking about Stitch and Futures. As you said, like for other applications, we can have something different. So that library abstract us, like everything is abstracted through that library. But like we were just wondering how exactly it works. Like for the library, how could be the implementation details?
Got it, got it. Okay, understood. So basically, we are just going at one level more deeper to understand how that is implemented. But I've right.
Yes,
But
yes.
but of course, it has, as you mentioned, right? Everything in the world of distributed system has to be asynchronous. So there is no question about that.
Yes, yes. Maybe there is some like there is this basic video we can talk about where he
Yeah.
says learn about inter microservice communication using asynchronous and synchronous strategies. I guess
Oh,
this might make us clear about that part.
okay. Can you send this video maybe on the
Sure,
chat?
sure.
Yeah, there is just one point to add here. Like, we were talking about asynchronous and COF. Okay, sorry.
Go ahead, go ahead, go ahead. Then.
Yeah, there is one challenge over there. Like, any libraries also kind of fundamentally it can use like, completable features and the fork lifting model to do the asynchronous approach. But there is a challenge over there, the library async approach, as well as like, event-driven mechanisms that we use like RabbitMQ or Kafka like that. The problem is like, let's say we have a source, I mean, source and the producer and the consumer side, right? Here the thing is, my understanding is if we are keep on producing and putting directly giving it to the consumer, let's say for example we have like one Java application and then RDBMS side, which is asynchronous approach, right? The challenge over there is like if something breaks, we really don't know, the receiver may not know because it's keep on sending the request, right? There is no otherwise what we need to do, we need to write the implementation in the code. But the idea for the Kafka, the things and all, they are kind of keeping that as a separate implementation so that any applications can reuse that approach, so that we don't need to write any typical or any explicit logic to handle asynchronism in the microservice level. So it's kind of a horizontal approach, and then there are a couple of advantages. Let's say if something breaks, and here in the message queue approach, it's gone, right? We may not be able to get it back, but there they are keeping storing it in the broker, so that if something breaks, it can heal themselves and it can continue from there. We can write logic like that. That's the advantage I've seen. But we may need to look at it like, why the asynchronous approach that we can do it from the library level differs from how that is differs from Kafka or kind of event driven tools itself, so that we don't need to write the asynchronous approach in the application level. We need to see, but just one point I could think of to add on that.
That's a great point, Deva. Maybe can you post this whole like this whole query in the group so that maybe we can keep track of that if we can find some material on that.
Yeah, sure. Yeah, I will make a note and then
And
post it.
then
Yeah.
just then just an extension to your point. This the Kafka and event driven system, they work on pub-sub model, right? So
Mhm.
I guess we can better inquire about how the pub-sub model is different than our traditional asynchronous communication, or if it is different, or if pub-sub model is just a way of managing it.
Yeah.
So this same thing, like right, what we saw here, this is also a sort of pub-sub model, but without queue, right? We have endpoints
Yes.
here.
Mhm.
We keep checking with the endpoint, but instead of that, in pub-sub model, we just subscribe to some topic and we just keep polling to that topic. So, and that topic is part of the Kafka queue, but here we have a separate endpoint. We just keep polling this endpoint continuously. Once we get 302, we just fire a different like call, and which will fetch us the response, and with that we will get a 200 response.
Yeah.
Okay, maybe let's go through this one. Looks like
Okay.
he might have explained something about asynchronous and synchronous strategies. If that goes through, then maybe we might go ahead here, and then later on we can search about how the PubSub model is different than traditional synchronous or synchronous communication.
Okay. Yeah.
Aditya, I'm not sure if I have cleared your doubt or not. This answers the one, right? We are just talking about the implementation details.
Got it. Got it. Yeah, that was helpful. Thank you.
Video, let's learn about inter-service communication, which basically talks about how microservices talks to other microservices or with each other. So for that, I'm going to take an example of e-commerce order processing microservice or order placing microservices. Let's understand how it was, how it used to be in monolithic, and then understand how it will be in microservice. So for example, this would be a function which basically handles placing order. In case of monolithic, it would have been much simpler, right? So this is a function called place order, in which there will be three different functionality. The first one is generating bill. As soon as we place an order, I want to generate a bill, and then basically I want to update the orders table with all the whatever order we want to place. And then we also notify the merchant that someone has placed an order. In that case, it would have been simple function call, because in monolithic, we have all the modules in the same server. So it would have been just a functional call, generate the bill, update orders table, and notify merchant. It would have been much easier. Now, so in case of microservices, when a user places an order, in the order processing microservices, the first thing it will do is generate bill. Since this is not the order processing microservices responsibility, this function should be able to somehow communicate to the billing microservice and get that thing done. How we can do is, as we learned, based on, we can do it in two ways. One is based on HTTP, the other one is RPC call, or you can do it in many ways, but these are the two ways which everyone prefers because of simplicity and usability and all the purpose. So when we want to do this action, what we have to do is somehow we have to call this microservice and give all the arguments which we needed, and then it executes here. As I mentioned, two ways is either we can do HTTP call or RPC call, and then we get the response back. And then we basically do the update orders table. This is actually the responsibility of the order processing microservices that actually runs locally, basically in the same instance. And then we have to execute notify merchant. This is not the order processing microservices responsibility. So we have to, again, call merchant microservice in it's the same way, either by HTTP or RPC. Okay, and then we get back the response, and we can now give back the response. The request started here, and the response after finishing all of this work. There are so many advantages and disadvantages doing this way. So what we are doing here is basically we're making a synchronous call from order processing microservices to billing microservices. And similarly, there are like two different synchronous calls, right? So this is not really the ideal way to do all the time. So let's learn how, what are the different advantages and disadvantages of using synchronous calls between microservices, and also learn how do we do using asynchronous calls. So let's understand what is synchronous inter-microservice communication. As I have already explained, synchronous microservice communication is basically calling different microservices synchronously. So this is client, this is API gateway. When a client makes a call to API gateway, this is going to call the microservice 1. And this microservices needs some data from microservice 2. What is actually happening is making a synchronous call in real time from microservice 1 to microservice 2 over REST or RPC, whatever, and then waits until this microservice 2 returns the response. And then it does whatever processing it is supposed to do, and then returns the response to API gateway, and then API gateway returns back to the client. So this whole cycle is basically synchronous way of communicating between microservices. So what are the advantages of having a synchronous intercommunication between microservices is, first of all, it is very easy to implement because we are all familiar with REST and HTTP calls. So it is much easier to implement intercommunication between microservices, and easy to handle different use cases as well, different errors, because we know what error the other service has written immediately in real time. So we can make an immediate decision and return back the response. That's one advantage. And the second one is real time, because we get the responses in real time. Even though it is calling many microservices, this could be calling one more microservices, but we get the real time response. It's not like we are waiting for something to happen in the back end. And then it's not really asynchronous, but it's like we get the response back for the same API call. So these are the advantages. And also, what are the disadvantages, if you ask? The first one is service availability. What does it mean? Is, say, for example, we are making a call to microservice 1, and microservice 1 is making one more call to microservice 2. This expects this service to be always available. For some reason, if this service is down, then the request, we won't get the complete response we were supposed to written by the microservice 1, because this service is down. We can't really get the information which we needed from the microservice 2. So we always expect this microservice to be up and running when MS1 microservice 1 is also up and running. This kind of violates the sole purpose of going to microservices architecture, because we always want these microservices to be isolated, or to be independent of the other microservices. But if we really need to be communicated, we have to have a synchronous communication between them. But what happens now is, because this is not available, this service is also dependent on this service. So basically, we have a tightly kind of coupled services here. But there are some use cases which we can't escape. In that case, it's fine to have a synchronous communication between them. The next thing is response time, the increased latency or the response time of the request. What could happen is, what if microservice 1 is calling microservice 2, and microservice is also calling microservice 3, 3 is calling 4, 4 is calling 5. What if this hop is too many, and all communications are happening in a synchronous way? Then there is latency added between every call from microservice to microservice. Then we might be expecting a lot of latency or delay in the response in this call. So that's one more problem. So always the idea is, if you know the other services, the dependent services are always high available, and they always return the response immediately with a matter of millisecond, or less than a second, then it's always good to have a synchronous communication between microservices. Otherwise, it is always good to consider asynchronous way of intercommunication between microservices. Now, let's understand asynchronous inter-service communication model. So in this case, suppose if our client wants to talk to this microservice 1, it makes a call to API gateway, and then API gateway makes a call to microservice 1. And here we have a synchronous way of communication. So when do we need a synchronous way of communication? Is basically, for example, there are a couple of microservices which also want their data to be updated. So first of all, you guys know that every microservice will have its own databases, right? So in that case, say for example, an order is placed in this microservice. So say this is an order microservice, and every other microservice also wants to know about when an order is placed. How do we basically send that information to all of these microservices that an order is placed? We can't have a one database which actually all of these microservices shares. This anti-pattern. So what we can do is we can build a data pipeline like system, which by using queues. What happens now is, when an order is placed to this microservices, this microservice basically sends a message to this queue. Okay, and then all the microservices which are basically listening to this queue will get updated that order is placed, and they will basically write into their respective databases. For example, like there is this microservice, or maybe, let's say this microservice has to send data to these two microservices, or these two microservices are dependent on this microservice. What happens now is, this microservice 1 basically writes some data, order data to these two queues, and it will be consumed by MS3 and also MS4. Okay, and it can also make a synchronous call here, or it can send that information here, and maybe MS2 is also consumed from there. So basically, every data exchange actually happens asynchronously using queues. And if you see here, there are no synchronous call. So the response will be much faster. All you have to make sure is the message is written into the queue. So this is one way to send the data to different microservices or share the data across microservices without using synchronous communication. It is always good to have a synchronous way of communicating between microservices, because for the reason now they are not really tightly coupled. Even though, for example, if this microservices goes down, this microservices is not really impacted from this because the queue is up. This microservices can always send a message to this queue. Even though this microservice is not available right now, when it comes back, it will always consume all the data which was loaded into that queue, and then it executes whatever it's supposed to do. The same is the case with these two as well. So this is not really tightly coupled to the service form, and they are not really, this microservice is not really affected by the availability of these microservices as well. That's the very important thing in microservices, because they are isolated now, right? This is what the asynchronous way of communication. So let's understand what are the advantages. The APIs will be faster for the same reason that we are not really making any synchronous call, and we're not waiting for the response to be returned from the other microservices. All we are doing is updating the queues, and then we are just returning the response, doing whatever process we are supposed to do. So the APIs will be much faster, and the services are decoupled now. Now, as I already mentioned, they are not really affected by the availability of these services. All we have to make sure is the queue is available. And the third one is works even when the services are down. That's one the same, right? And the fourth one is no need for service discovery. It's also one more important thing. We all understood what is service discovery. Now, this microservices doesn't really care about what is the network address for this microservice, this and this. All it has to know is what is the address for the distributed queue and the queue name or the topic name. That's all it need to know. And that can be hard-coded. So we don't really need service discoverability here. So that's the advantages. Now, what are the disadvantages of using asynchronous way of communicating between microservices? Is the design will be complicated. So if you see in the previous synchronous way of communication, it was very simple, right? But now there are a lot of components here. There's queue, there's these microservices are talking to this queue, and this also talks to this queue. There is monitoring in between, and this is distributed. We need to maintain this queues. The design will be complex, but the system works well and it is decoupled. The second disadvantage is process latency. What it really means is, say, for example, if this queue is overloaded, and if the service is not really scaled, it could be that whatever it is this microservice was supposed to do might have been delayed than the expected time. If it was synchronous processing, then we are sure that by the time we get the response from microservice 1, we have finished all of the processing. But in this case, we can't expect always this microservice has finished its job. So there could be an additional delay, or if it is overloaded. The third one is monitoring costs.
Yeah. So I think this was mainly about like asynchronous communication using queues, right?
Yeah, this clearly explains the question that I think Aditya had, right? Like, now, what if very simple async communication between two microservices, and what is the advantage of using queues? I mean, the Kafka or kind of some kind of brokers.
Yeah, this was helpful.
Yeah.
Thank you, guys.
Yeah. So one thing I was wondering, if there is asynchronous service communication without using queues, like without message queues, there could be other ways, right? The one we were talking about, Deva, was without queues, right?
Yeah, I mean, the first one that he was explaining, right, MS1 to MS2, that itself we can do it using, like, in Spring, there is some async annotation or some other way, indirectly we can do it in Java also between MS1 to MS2. But there are other challenges. Let's say you wanted to expose to other multiple microservices, then the queue operation is the best approach. Like that.
And this, I was particularly interested in this architecture. Like here, we don't need queue, right?
Yeah, here, this one, I think it talks about the client and server architecture. But here I'm seeing there should be some drawbacks also. Like, this is overwhelming the client, right? Let's say, what if it's a client is a UI and it requested the endpoint, and let's say the endpoint is taking 15 minutes. What the client will do, maybe it may poll continuously with the second get call, right? But it may say 202, 202 like that, because it's not, I mean, the work is not done. And then till that time, the UI may not be able to show the processing screen or something. This could be a best approach for some kind of a batch process, like, anything like,
Yeah,
how this will be good for the UI, which I am not sure, like this async request response approach.
I guess in single page applications, they usually try to re-render that particular component, right? So let's say if we are checking the status for order completion or something like that, it might take like it might give some message like we are still waiting for the order confirmation. But by that time, it can let the user do all the other stuff. So we can have a simple component, and that component will itself will show the status that we are awaiting the confirmation. By that time, the user can perform other actions.
Okay. Yeah, got it.
Yeah. So, and then making this itself scalable. Like if we are trying to make this scalable, then the Kafka things comes in, right? Like for the status endpoint, we can keep we can maybe go to subscribing some topic. Like subscribing the topic means again polling to the same place and then checking if the response is ready or
Yeah.
not.
Yeah.
So
So this is
this is a appending operation, like append like maybe enqueuing to the queue. This could be dequeuing from the queue, and this is like just subscribing to a topic to check the status.
exactly. So that could be, I mean, understanding that could be like three topics involved. I mean, like if
Yes.
no, the first one is an endpoint, but the status endpoint could be I mean, the understanding the particular queue status, right? What exactly happened, and then the output can be written from that.
Yeah. So I guess while these guys, let's say if we have to convert this architecture into queue, like a Kafka queue type or message queue type architecture, then while the post operation is happening, it will be posting to some topic, okay? And that the endpoint for that topic could be somewhere here. And this is basically the topic endpoint. Uh, Posting to a topic means while checking for the status, we will checking for that topic. So there could be like status 1 endpoint, status 2 status 2 endpoint, status 3 endpoint. So first one is like status 1, which we can call as topic. So while this post request is going on, it will post to status 1 so that the status can be checked to status 1 endpoint itself. If it is posting to status 2, then it will check to some other endpoint.
Yeah. So I
Okay,
you,
let me make it clear through this.
my understanding is like here, it should do both REST as well as the Kafka implementation also, right? So definitely there will be three URL, REST URL. One is I'm thinking like, slash API endpoint, then slash status, then slash output. Let's assume like, we have three endpoints.
Yes.
So the application would do the first call for API endpoint and it will send out an object, right? And then that object, we should have some internal process should be implemented. That microservice, the API endpoint microservice should put a entry to the topic, and that topic will be read by one more microservice, and then that will send the status update to one topic called status endpoint. So there it will say submitted or started or some status, and then that microservice will keep on working. And then let's say once it finishes the work, it will send the status update to the status microservice, which is like completed. And then there should be some kind of one more output. I'm just thinking like then the output object should be rendered from one more microservice, which is slash resources. So kind of in that way, then the clients can do a REST call, then get the appropriate things, right?
Yes, same thing. Like same thing, maybe to like to pictorially we can see it like this. So while posting the first post request, it will just post it to some topic S1. Okay, let's say if it posts to S1, then the status endpoint you are saying like so this is S1 endpoint, right? So we will check the status here. We will keep checking the status here. Okay. And if the response if we get 302 response from this S1 itself, then we will initiate a REST call, and we will dequeue it from the queue. And let's say what if this is something else. This was, let's say, for items. Now we are doing it something like for products. So we will just append it with different topic. So like topic S2, and then while checking the status, we will check it to S2. And if the response is if this sends 302, then we will check with the respective resource URI, which will be different than this one.
Yeah, but just wanted to add, the rest is slightly different from the Kafka protocol, right? So
That we
yeah,
need to check, I guess. That we need to check. I guess going deeper into this, we might be able to
okay,
understand that.
okay. But I got down. I mean, so the client that we are saying, the client, we will give them a separate endpoint, like, this is your post call URL, and this is your URL, and this is the, I mean, status get call
Yes.
URL, and this is your resource URI get call
Yes.
URL. So the client will have 3 different endpoints, but in the server side architecture, what we will do, we have to have our own topics so that we can push those topics, and then there should be a microservice with the end get call opened up so that they can get the status. But internally, we are playing around everything with the asynchronous approach through the Kafka topic implementation, right?
Yes.
Yeah.
Yes. Exactly. Okay. Let's go back to the initial discussion.
Yeah.
So it said, is it clear to everyone? Just wanted to know if anyone has any questions related to anything related so far whatever we have discussed. Okay. Interrupt me in case if you have any question or anything. Okay, so it says if an operation is too slow to perform inline, you can use a message queue with the following workflow. An application publishes a job to the queue, then notifies the user of job status. A worker picks up the job from the queue, processes it, then signals the job is complete. The user is not blocked, and the job is processed in the background. During this time, the client might optionally do a small amount of processing to make it seem like the task has completed. For example, if posting a tweet, the tweet could be instantly posted to your timeline, but it could take some time before your tweet is actually delivered to all your followers. Yeah. So I guess our view, like the user's view, could be different than the followers' view. For followers' view, the data should be consistent over all the shards or over all the data, the partitions that are storing the tweets. Once it is once it is replicated over everywhere, then only we can initiate a response or initiate some response for the followers, or while rendering it to the timelines of the followers. Redis is useful as a simple message broker, but messages can be lost. Okay, so I guess this is something like without acknowledgement, right? If there is no acknowledgement, the message could be lost.
So the Redis can be used for messaging also, right? Usually Redis used for caching, right?
Yeah, I guess caching
But it can.
message broker could be different thing. That's what I feel. Not sure if same the same data structure or the same service could be used in a different way or something like that. I'm not sure about that. Let's check. Uh, I guess anyone have any idea about
I think
this as
in the
message queue?
in the second one, they mentioned a difference between RabbitMQ and Redis. So this may give us a RabbitMQ is kind of equivalent to Kafka kind of thing, right?
Yes.
So this will tell us, I think, how that is differed. Head-to-head comparison between.
Okay, it says Redis is an open source in-memory data source which can function as a message broker, database, and a cache. It supports various data structure such as string, hashes, list, sets, sorted sets with range queries, bit, bitmaps, hyperlogs, geospatial indexes with with radius queries and strings. It is quite fast and lightweight. Here we will discuss top 9 differences between this. Okay. It can function both as message broker, database cache. It is very fast, lightweight, and hence grabs the attention of developers around the globe. It can be scaled up to send around million messages per second. Kafka producers don't wait for acknowledgements from the broker, so brokers can write messages at a very high rate, resulting in higher throughput. How about Kafka in Redis? Why? You have to opt for SSL in paid service.
I think it's just overall. I mean, Redis acts as a message broker, but I think since it's not a dedicated message broker, it's losing a lot of functionalities, I think. But RabbitMQ or Kafka is kind of mainly they focused on message broker alone, right? So there, I think I see that they have a lot of advantages.
Yeah, yeah. As you said, like message are not lost once stored in RabbitMQ. So message acknowledgements are part of it. Okay, yeah, maybe this is something we need to check. Not sure how they're doing it. RabbitMQ is popular, but requires you to adapt to the AMQP protocol and manage your own nodes. Okay, so it's an advanced message queuing protocol. Okay. Uh, something this. Okay, I guess this looks like a good one.
Hi everyone, welcome to my channel. I am back with another tutorial. Hi everyone, welcome to my channel. I am back with another tutorial which is on RabbitMQ. This will be a complete tutorial on RabbitMQ in Java. So let's get started. This tutorial will be on Java. We will be mostly using AMQP client, which is AMQP, to communicate with RabbitMQ. As part of this tutorial, you are going to learn the basics of RabbitMQ and AMQP, why we really need a messaging system. Then I will also explain you how to set up a RabbitMQ server in Docker and Docker Compose. There is also a handy user interface to look into that in brief. We are going to try out several examples in Java as well as in Spring AMQP. You are also going to learn good JSR mix. And like I mentioned, finally, we will look into a basic idea about Docker and how to run or contain that 3 of system designs. Monolith really need a message broker. Software architectures these days are rethinking their system designs. Monolithic applications are evolving into microservices and infrastructures are moving to cloud. Messaging is undoubtedly an important facet of any microservice architecture. RabbitMQ is a message broker used to exchange data between processes, applications, systems, or servers. You see, these days, everything that we are building, we are talking about microservices or at least service-oriented architecture. So in a microservice architecture, a service A needs to talk to the service B. And the way they talk to each other is using a message broker. Just for your understanding, you can consider a message broker like Indian Postal Service, where in every letter that you send, the destination, you specify the address, and the message broker, which is the Indian Postal Department, takes care of making sure that your letter reaches the right destination. So what exactly is RabbitMQ? RabbitMQ is an open source message broker. It is licensed under Mozilla public license. It was originally developed by Pivotal Software Inc., which is now a part of VMware. RabbitMQ is written in Erlang language, which is designed for distributed, fault-tolerant, and soft real-time systems. RabbitMQ is quite popular, specifically in microservices architecture. It has several advanced features, which we will look into it little later. So what are the features or benefits provided by RabbitMQ? So first of all, it is an open source software, or you do not need to pay the license fee to anybody. It supports multiple messaging protocols like AMQP, MQTT, STOMP, HTTP. But as part of this course, we will only use AMQP. It is lightweight. A single instance of RabbitMQ can run on less than 40 MB of RAM. There are several client libraries available in different programming languages like Java, Python, JavaScript, Erlang, and so on, using which you can write RabbitMQ based applications. Another amazing feature that is provided by RabbitMQ is support for third-party plugin, using which you can extend the capability of RabbitMQ and write custom functionalities. For example, if you want to persist the messages in a RDBMS, you can do that using a custom plugin. Using RabbitMQ, you can create scalable applications. RabbitMQ also provides handy tools for monitoring RabbitMQ server. Next, we will understand what is AMQP. You see, RabbitMQ is a server or is a message broker. You need a protocol to communicate with the server. You can use HTTP or there is something called AMQP. So AMQP is an open standard for passing business messages between applications or organizations. AMQP stands for Advanced Message Queuing Protocol. It is designed keeping interoperability in mind, which means two services written in different programming languages should be able to communicate via RabbitMQ using AMQP protocol. AMQP also focuses on security, reliability, interoperability, and open standard. AMQP is a protocol which is supported by several message brokers. RabbitMQ is one of them, and we are going to learn RabbitMQ using AMQP protocol. So there are several products which support AMQP protocol. Apart from RabbitMQ, there are also other tools like Microsoft Azure Service Bus. There is MQLite that also supports, and there are several other tools that supports. I also want to quickly talk about the tutorial that I have created as part of.
Okay, so I guess Deva, the one which we were discussing about, it's not REST. The underlying communication is not REST, right?
Yeah. I think RabbitMQ supports multiple messaging protocol like AMQP, STOMP, like that. But Kafka, I think they are not explicitly saying, they are saying something like a binary protocol. I think they use some protobuf or something for their message communication. So we use their API and we send an object, right? So we are the producer. Producer is also a library, Java library, which we use as that. But underneath, I think it uses some kind of a protocol. I'm just talking about the Kafka one, but here it is explicitly saying what type of protocol it is. But I think in the RabbitMQ, we can configure what type of message, protocol message that we want the RabbitMQ client to send it to the server.
Okay. So I guess this is one thing which explains same thing, I guess, Deva, what you were just talking about. There are two ways, basically, REST versus MQ, right?
Yes.
You can go through this quickly.
I think RabbitMQ also supports HTTP. In that video, I've seen HTTP also. So we can use HTTP also to send a message.
Let's check it then. Oh, okay. It allows AMQP as well as HTTP.
HTTP, STOMP, and MQTT.
Okay.
But for messaging, HTTP is not a right option because it has a lot of extra baggage in it, right? That's the reason we are going for a scalability and other things, so that AMQP is kind of defined, that protocol defined only for messaging.
Yes, so I know about MQTT. So in IoT applications, they don't afford to be they don't afford the payload to be heavier as that in HTTP. So HTTP generally perceived as a heavier payload. For a lower bandwidth kind of applications where concern, or where we are talking about smaller devices which can't handle the burden of heavy payloads, they go with MQTT. And MQTT is connectionless protocol. It runs with PubSub model, and since it is connectionless and without PubSub model, like the payload is in fact very small, just a few bytes, just like that. So I remember once there was some video where they were talking about NASA's services. When NASA wants to communicate with their like satellites with some other type of like critical scientific services, they go with MQTT because it is lightweight, and it actually is highly scalable because of because it uses lower bandwidth.
Okay.
So that one thing I feel is connection oriented protocol and size of payload. That these are the things I think can be replaced with some other queuing thing instead of going with REST. So that is one thing, I guess. That is one point where we might want to use different protocol.
Okay.
But then I guess here they are saying one of the biggest differences in REST implies synchronous processing while MQ is often asynchronous. As you already mentioned, MQ is a way to decouple producer and consumer. So they don't have to be online at the same time, but the system would still be functioning as a whole. If your use case implies a low latency response, like a user with a browser, you need synchronous semantics. Like, yeah, so I guess this is in terms of a typical user specific communication, right? If your use case implies a low latency response, like a user with a browser, you need synchronous semantics. And in this case, MQ is just a different protocol. If latency is not a concern, there is messaging. There's messaging goes only in one direction. Message queue may be a very viable alternative. One thing MQ provides for free is load balancing, some level of horizontal. I guess I'm not sure about HA. Is it
High availability?
yeah,
I'm
high
just
availability.
making up.
My bad. Yeah, high availability. Load balancing, because in Kafka they do horizontal scaling, right, to make it highly available.
Yeah.
On the consumer side, REST is much more flexible in terms of client server compatibility. You can run a REST client nearly on every platform, which is not the case with MQ. I guess this is the reason why some people claim MQ is getting obsolete. For this reason, MQ is not good for public APIs. However, for communication between two server systems, MQ still remains a very good option. A unique feature of REST is that it allows you to fully mimic the web behavior of your resource, hypermedia. That is, one resource contains a reference to the other, and so on. MQ cannot provide anything like that. Performance may be another concern. I cannot give any exact figures, but MQ tends to have greater throughput. Yeah, this is the point, Deva. I was talking about MQTT, right?
Yeah.
So HTTP and MQTT are almost similar, except MQTT is more towards queuing, like for asynchronous queuing. In some rare cases, due to security requirements, clients cannot connect directly to a server. In such cases, MQ is pretty much the only way to send data to the server. To summarize, as a rule of thumb, I would use REST for public APIs or where synchronous processing is needed. MQ when only a limited amount of server-side systems is involved, and asynchronous processing is acceptable, or REST performance is not enough. Yeah, I guess this is a perfect explanation going with REST versus MQ for any Kafka or RabbitMQ.
Yeah, the MQ, the first one, what they're trying to say, when only a limited amount of server side systems is involved.
So we need different clients, right? We need MQ clients for that. So whichever client or whichever system implements the MQ, they only can talk with.
Okay. Okay.
Whereas REST, like almost every single system has support for REST.
I got it. Yeah.
So wherever we have support for HTTP, we have a support for REST, right?
Yes.
Like,
But for MQ, it's not the same, right? I think that the system should work for that. Okay.
Yeah. So I guess so AMQP is one of the MQ protocol, right? Just like MQTT.
Yes. But I think they may have like Stomp or MQTT or AMQP. They may have their own internal differences, but all of them are kind of messaging protocols.
So they are usually called as pub-sub model as well. Like if you see, it says in MQ model, the producer and consumer need not be running at the same time. The producer and consumer do not interact directly. The message broker takes care of handling the messages and persisting it, etc. Both point-to-point and publish-subscribe models are supported. In a publish-subscribe model, a message can be consumed by more than one consumer. There are just some basic points that differentiate them. There are enough posts also that so that talk about arrest and MQ. Okay, yeah. So I guess almost all the MQ could be using either producer consumer or pub sub kind of model.
Yes. But I see, like, I think the message queue, right, as a broad term, that can always will go with either client or like pub-sub model, right? The topics are queues, right? That's the idea. But I think the protocol level, then that could vary. Like, I see the RabbitMQ, but the RabbitMQ or Kafka, both of them are pub-sub model only. But underneath, they have a different implementations, right? I mean, RabbitMQ can use like these protocols, AMQP or all these things, and Kafka can use a different protocol, but underneath, both of them are doing like pub-sub models.
Yeah, I guess we can check with that. Kafka protocol versus
RabbitMQ.
mm,
When we compare with the performance, I hear that like Kafka is a good one compared to RabbitMQ in case if there is million records or something.
okay. Yeah, Kafka is definitely horizontally scalable. So wherever we want scalability, they usually go with Kafka. Like Kafka is gaining grounds recently. That's what I have read.
Okay.
Yeah, I have been asked to evaluate RabbitMQ instead of Kafka, but found it hard to find a situation where message queue is more suitable than Kafka. Does anyone know use cases where message queue fits better in terms of throughput, durability, latency, or ease of use? RabbitMQ is a solid general purpose message broker that supports several protocols such as AMQP, MQTT, and SPOMP. It can handle high throughput. A common use case for RabbitMQ is handle background jobs or long running tasks such as file scanning, image scanning, or PDF conversion. RabbitMQ is also used between microservices where it serves as a means of communicating between applications, avoiding bottleneck passing messages. Kafka is a message but optimized for high throughput ingestion data streams and replay. Use Kafka when you have the need to move a large amount of data, process data in real time, or analyze data over a time period. In other words, where data need to be collected, stored, and handled. An example is when you want to track your user activity on a web shop and generate suggested items to buy. Another example is data analysis for tracking, ingestion, logging, and security. Kafka can be seen as durable message brokers where applications can process and reprocess stream data on disk. Kafka has a very simple routing approach. RabbitMQ has better options if you need to route your messages in complex ways to your consumer. Use Kafka if you need to support batch consumers that could be offline or consumers that want messages at low latency. So I guess this is somewhat similar to the timeline kind of services. So if we see the system design test, like the examples or the interview questions, uh, mostly for timeline service, they go with Kafka, because Kafka is helps us in real time, like real time data retrieval or something like data streams. So wherever we want to make some pagination or some timeline kind of service, they go with Kafka. But for inter-process communication, I guess RabbitMQ is still favorable. That is one thing. Not sure like what is the reason for inter-process communication being favored in terms of RabbitMQ.
Okay.
So it says, in order to understand how to read data from Kafka, we first need to understand its consumer and consumer group. Partitions allow you to parallelize a topic by splitting the data across multiple nodes. Each record is in a partition is assigned and identified by its unique offset. This offset points to record in a partition. In the latest version of Kafka, Kafka maintains a numerical offset to each record in a partition. A consumer is in Kafka can either automatically commit offset periodically, or it can choose to control this committed position manually. RabbitMQ will keep all states about consume, acknowledge, unacknowledged messages. I find Kafka more complex to understand than the case of RabbitMQ, where the messages is simply removed from the queue once it's acknowledged. Okay, so I guess this is more like partitioning or a larger kind of fault tolerant system, right? In terms of Kafka. But whereas RabbitMQ, it is just simply about consume, acknowledge, unacknowledge kind of structure.
Yeah, I see the main difference. Like Kafka, we can replay, but in Rabbit, we cannot replay because it's deleting the message, right? Once it's acknowledged.
Yes, I guess. And is it the case that RabbitMQ will just flush it out? It won't have any snapshot of the data that has been handled so far. Because in Kafka, we can choose to have a snapshot of data on some RDBMS or some external storage. Right?
Yeah, by default, I think what it does is keeps the, I mean, without, but we need to add some plugins to get that, write it into the RTBMS or anything. But by default, it uses a NoSQL and put it into the file system as like a binary data, so that the consumer, let's say if a new consumer comes is, and if they wanted to replay it from the start from that particular topic, it can do that. But in RabbitMQ, we cannot do that, because if one I think if one particular consumer read the message and if they're acknowledging, then I think RabbitMQ is deleting the data itself.
Got it. So how about saying this, like in terms of architectural design or in terms of design choices, wherever we are handling more data, we can go with Kafka, and wherever we are handling only communication and we need high throughput, we can go with RabbitMQ.
Yeah.
Is it safe to say something like this? Because
yes,
like it's clearly mentioned here that it can handle high throughput, right? We were able to read it like multiple places that it is able to handle high throughput, or even in case of MQTT they were saying so.
Yeah, I see the main difference. If you see the bold letter now, RabbitMQ, they say it's message broker, but the Kafka, they are saying durable message broker. That's the place that the durability comes in, because anytime it can get the data back, because it's keeping the data. Otherwise, we have to mention it, right? Like when it should delete the data. Otherwise, it will keep on keeping the data, I think. But that's where the durability comes in, I think.
Yeah, and to make it durable, maybe we are aiming consistency here over availability. So the performance might affect in that case.
Okay.
So to make all the partitions consistent, our response time could increase, right?
Yeah, I mean, it in case if the consumer requests data, it should go back to a multiple partition to gain the data back, right? To send it to the consumer.
So I was just thinking about some basic CAP theorem, like nothing very special. in general, if we want consistency, or maybe if we want it to be durable, we might want to process it into our structure, or like let's say replicating it over partitions before sending back the response. Yeah, maybe that could be one thing we could in fact see what kind of system design test cases are system design use cases are there. Through that maybe we might be able to understand, but still we are not able to find a clear cut protocol that Kafka is using, right?
I think it's uses protobuf, but we may, because Kafka is implemented using Scala.
Oh, is it? Okay.
Yeah, it's an Apache product. So if we I think we would be able to get the code base, and I remember I tried to look for the code, but it was written in Scala.
Okay. So one thing I saw this comment here. It was like it says I also understand it this way: REST versus RPC and HTTP versus AMQP. So usually REST works over HTTP, right? We are not sure, like RPC is mostly over HTTP too, or the protocol could be some format of customized payload over HTTP. Just that. But in terms of HTTP and AMQP, I guess these are totally different thing than the RPC versus REST, right? So not sure if we can say like Kafka and like the protocol for Kafka or RabbitMQ could be similar to RPC. It should be totally different thing.
Yeah, if you search like protocol used by Kafka, I see Kafka uses a binary protocol over TCP. Protocol used by Kafka. I see that network Kafka uses a binary protocol over TCP.
Okay. And basically this it is anything but HTTP, right? Yes, I guess so. We okay, here on Wikipedia page they have mentioned something like that. Kafka uses binary TCP based protocol that is optimized for efficiency and relies on message set abstraction that naturally groups messages together to reduce the overhead of the network round trip. I guess this is what Aditya was also talking about, the batch processing, right? Okay, so this is entirely different thing.
Okay.
The underlying messaging protocol is a binary protocol. Consumer API built on top of Kafka messaging protocol offer a reference implementation of Kafka consumer and producer client in Java. The underlying messaging protocol is a binary protocol that developers can use to write their own consumer or producer clients in any programming language. Okay. Binary protocol is a communication protocol which utilizes all values of a byte, as opposed to text-based protocol, which only uses values corresponding to human readable characters. Okay, so basically serializing the data and then sending it over the TCP, right? Yeah. Okay.
Yeah, and moreover, they are saying this unlocks Kafka from the Java virtual machine ecosystem. So even though the product is written in, because it's in Scala, which is a JVM ecosystem, right? But they wanted to get this workable for other programming languages as well.
Okay. Yeah, this is interesting part. Yeah. So that's why Scala should also support it, right? Like Scala is also JVM language, like just like Java Kotlin and all the
Yeah.
other. Makes sense. Great. Yeah. Cool. Shall we stop here, Deva? I guess
Yeah.
we are.
Yeah. Yes.
Okay. Like, sorry to deviate a bit from topic, but the thing which is clear to us is basically the protocol is entirely different for message queuing. Something like advanced message queuing protocol for RabbitMQ, or RabbitMQ has a couple of other protocols as well. And for Kafka, it is binary protocol, right? So the communication part is entirely different here. And another thing was about REST. Usually the REST type of system, they go with HTTP, which is correct connection oriented, and which is by default a synchronous type of communication. So since we want to keep it asynchronous here, we might need different type of protocols. Okay, shall we stop here?
Yes.
Yeah. Thank you, everyone.
Yeah. Thank you all.
Yeah, thanks everyone. But, where to get these recordings, just in case?
Okay, let me ask Asim. We were actually discussing if we can upload this to YouTube, and then all of the other people can just download it from YouTube or watch it on YouTube. Once it is done, we can delete it because the storage could be an issue for storing, let's say 4 to 5 recordings. It will just it will be too much of storage for anyone to do that.
Sure. Thanks.
Thank you, everyone. Asim, are you there? Asim?
बस हो गए
रिकॉर्डिंग हो रहा है क्या? मतलब
लैपटॉप चेक करता हूँ एक सेकंड
हाँ, अगर मैं मैं अगर मीटिंग एंड करूँ तो अपने आप वो रिकॉर्डिंग तुम्हारे यहाँ पे जनरेट हो जाएगी ना?
आई थिंक सो। सेकंड होल्ड करो, मैं रिकॉर्डिंग स्टॉप करता हूँ.